So now we will be discussing about conversion of NFA with epsilon transition to DFA. Now we have already seen in the last discussion how to convert NFA with epsilon transition to NFA without epsilon transition. Okay, now you are already aware of, if I want to convert this NFA without epsilon transition, that means normal NFA, to a equivalent DFA, then there are two methods, direct methods and indirect method. So you can use any method. So I will discuss now here direct method for quick understanding. So in last example, what we have seen, our NFA with epsilon transition was Q0, 0 with epsilon to Q1, Q1, and there is a final state for Q2 to an epsilon transition, and we have find out the NFA without epsilon transition as, so we have seen that there are all the three states as final states, Q1, Q2, there was self loop here with 0, with 1, with 2, and with Q0 we can move to Q1 with 0 as well as 1. Then from Q1 we can move to Q2 with 1 as well as 2, and I can move to Q2 with either 0, 1 or 2. Okay, so this was our NFA without epsilon transition move. Now we are interested in finding out the equivalent DFA, okay, using direct method. So how we have used a direct method, if you recall, so what we will have to do, what was the table for this? So the table for this was there were three columns, is it? 0, 1, 2, then Q0, Q1, Q2, all are final states, and we have seen that Q0 on 0 moves to 3 states, is it? It is Q0, Q1, Q2. Then Q0 on 1 moves to Q1, Q2, on 2 moves to Q2, is it? Then Q1, here it was a 5, and then again it is Q1, Q2 and Q2, and again it was 5, 5 and Q2. So this was our NFA without epsilon transition. Now we are interested in finding the equivalent DFA for this. So recall the method how we have find out the DFA. So how many states will be there? So definitely here what we will do with the direct method, Q0 on 0 moves to this state. So very first I will make a Q0 state. Okay, since this is a final state as well as I need to mark it as a Q0. Okay, and what it is, Q0 on 0 moves to which state? A state which is named as Q0, Q1, Q2. This will be also final state because all are the final state, right? So Q0 on 0 moves to a state which is named as Q0, Q1, Q2. Next, Q0 1 on 1 moves to a state Q1, Q2. So I need to have one more state here. Moves to which state? Q1, Q2. Right? Then Q0 on 2 moves to a state named as Q2. Okay, now next is, so we have got how many new states? Q0, Q0 turn is over for all this. Okay, and then you are getting how many new states? Q2 is already available, Q1 is not there. So now we have to consider the next state. So Q1 on, so I need to make one state as Q1 which will be again a final state, right? And here what we will write, Q1 on, better I make it here so that it will be more nearer. So Q1 on, is it Q1 on 1 moves to Q1, Q2. Then Q1 on 2 moves to Q2, right? Next, Q1 turn is over. Next is Q2 on 0 moves nowhere, Q2 on 1 moves nowhere, and Q2 on 2 moves to Q2. So there will be a self loop. Is it? Now this will be here. So have I considered all the states? Q0, Q1 and Q2. Now we will draw a transition table for this. So how many states will be there? So it is having Q summation. How many input symbols? There are 3 input symbols, 0, 1 and 2. Now states are Q0, Q1, Q2, Q1, Q2 and Q0, Q1, Q2. Is it? So like this we will be having how many states? 5 states, where this is initial and all are the final states. Is it? Now we will fill the values accordingly. So Q0 on 0 moves to Q0, Q1, Q2, Q0, Q1, Q2. Q0 on 1 moves to Q1, Q2, Q0 on 2 moves to Q2. Next, So this is all single states. Then Q1 on 0 moves nowhere. Q1 on 1 moves to Q1, Q2. Q1 on 2 moves to Q2. Next, Q2 on 0 moves nowhere, on 1 moves nowhere, but it moves to itself. Next, Q1, Q2. Now we have not considered Q1, Q2. We need to do entry for this. So Q1, Q2 on 0. So Q1, Q2 on 0. We need to do union of these two. So it is going nowhere. Q1, Q2 on 1 moves to union of this. So there will be a self loop here, right, on 1. And Q1, Q2 on 2 moves to Q2. Similarly, we have not considered. So what are the entries? Q1, Q2 on 0 moves nowhere. Q1, Q2 on 1 moves to itself, that is Q1, Q2, and here it is Q2. Same way, now there is a turn of this new state. We need to consider it, right? So Q0, Q1, Q2 on 0. Q0, Q1, Q2 on 0 moves to what? Same state, that is Q0, Q1, Q2, right? This is a complete one state, the same. Then, so I need to mark, once I will complete it, then Q0, Q1, Q2 on 1. So we need to do union of all these 3 rows. So it will be Q1, Q2. Similarly, Q0, Q0, Q1, Q2 on 2 moves to Q2. Right? Now this will be your table. Now as you can observe, all these are the final state. So here, before drawing this diagram, or we can do, so here again Q0 on 0 moves to itself, right? Q0, Q1, Q2 on 1 moves to Q1, Q2, and on 2 it moves to Q2, right? So now what we have to do, if we have observed this table properly, we can say that there is a possibility of minimizing this. This is a DFA, right? So we can minimize this DFA. So check, is it possible? Yes. See this row Q0, Q1, Q2, Q1, Q2 and Q2, Q0, Q1, Q2, Q1, Q2 and Q2. This is final state, this is final state. So I can say that Q0 is equivalent to Q0, Q1, Q2, right? Similarly, so this will be discarded as per our DFA minimization rule, and every Q0, Q1, Q2 will be replaced by what? Q0. Similarly, do you find any more similarity? So see Q1 and Q1, Q2. These 2 rows are also equivalent. So every Q1, Q2 will be replaced by, so we need to remove this. Why? Because Q1 is equivalent to Q1, Q2. Okay. So after removing these 2 rows and replacing Q0, Q1, Q2, this will be replaced by what? Now this will be now replaced by what? Q0, right? Similarly, this will be replaced by Q1. Okay. Similarly, this Q1, Q2 will be also replaced by Q1. Okay. So what will be my final transition table? So my final transition table will be what? Q summation 0 1 2 Q0 Q1 Q2 initial state, all are final state, and now I will be replacing this var with Q0 Q1 Q2, then dash Q1 Q2 dash dash and Q2, and my graph will be final DFA will be Q0 on 0 moves to Q0, then Q0 on 1 moves to Q1, then Q0 on 2 moves to Q2. So Q0 on 0 moves to a single state, Q0 on 1 moves to a single state, then Q0 on 1 input moves to a single state. Turn of Q0 is over. Now Q1 on 0 moves nowhere, Q1 on 1 moves to itself. Okay, see there is a self loop here no place was there, so here it is same one. Then Q1 on 2 moves to Q2, so again single transition, single state. Now Q2 on 0 and 1 moves nowhere, but with 2 it is moving here. So I hope you have understood how we will be having a final DFA for the given NFA with epsilon move. So I have used here direct conversion method NFA to DFA. You can verify it with indirect method as well. Now can we verify whether it is also accepting same language which we have seen? All these strings will be acceptable by this. Just check. So if it is 0, since it is moving to Q0 with 0 and it is a final state, it is acceptable. 1. So from Q0 with 1, it is moving to Q1, which is again a final state, acceptable. 0 0 1. So with 0 0 it will be Q0, and with 1 it is moving here. Now here 0 1 2. So now Q0 on 0 moves it here, with 1 it is moving Q1, and with 2 it is moving here. Now tell me, if it is having 0 to 1, will it be acceptable? It is not acceptable. Why? Because 2 is not followed by 1. Here 1 is following 2, which is not allowed as per the language definition. And we can verify with 0 I will be here. Okay, with 2 I will be going to Q2 state, right? But after Q2 state with 1, there is no transition available. From Q2 no transition is available. See, Q2 on 1 moves nowhere, so no transition is available for 1. So this will not be acceptable by this DFA. Okay, so I hope you have understood it. Okay, how to convert the NFA with epsilon transition to without epsilon transition. Thank you.